A carburetor is a mechanical device used in internal combustion engines to blend air and fuel into a combustible mixture that the engine can ignite. Its primary purpose is to maintain the correct fuel-to-air ratio under various operating conditions: starting, idling, acceleration, and full throttle. Carburetors have been a fundamental component of gasoline engines since the late 1800s, though modern engines increasingly use electronic fuel injection systems. Despite this, carburetors are still widely used in small engines such as those found in lawnmowers, generators, and other outdoor power equipment due to their simplicity, reliability, and ease of maintenance. The science behind it: Bernoulli's principle. At the heart of a carburetor's function is Bernoulli's principle, which states that as the velocity of a fluid, in this case, air, increases, the pressure within the fluid decreases. Inside the carburetor, incoming air flows through a narrowed passage called a venturi. As the airspeed increases through this constricted area, the drop in pressure creates a suction effect. This vacuum draws fuel up from the float bowl into the airstream via jets, where it atomizes, turns into tiny droplets, and mixes with the incoming air, forming a combustible mixture that the engine can use. Main components and their roles. A typical carburetor consists of several key components, each serving a specific function. Float bowl, a small reservoir that holds fuel at a regulated level. Float and needle valve work together to control the fuel level in the float bowl. As fuel is used, the float drops, opening the needle valve to let more fuel in. Once the bowl fills, the float rises and closes the valve. Throttle plate, butterfly valve regulates the amount of air entering the engine, thereby controlling engine speed and power output. It is connected to the accelerator or throttle lever. Choke plate, a movable plate that restricts airflow at startup, enriching the fuel mixture to make cold starts easier. Main jet delivers fuel from the float bowl into the venturi for normal engine operation at higher speeds. Idle jet supplies a small, steady amount of fuel for engine idling or very low-speed operation. Air bleeds, small air passages that mix with fuel before it exits the jets, helping to atomize the fuel and ensure efficient combustion. Emulsion tube, in some designs, mixes air and fuel before the mixture reaches the venturi, enhancing fuel atomization and responsiveness. Operational circuits in the carburetor. The carburetor uses two main circuits to deliver fuel depending on engine speed and load. Idle circuit: this circuit is active when the engine is running at low speed or idling. It ensures that the engine receives a consistent, low-volume supply of fuel, even when the throttle is nearly closed. Main, high-speed circuit: as the throttle opens and the engine demands more power, the main jet and high-speed circuit take over, delivering a larger quantity of fuel to support acceleration and higher RPMs. These two circuits operate independently but are carefully calibrated to transition smoothly, providing consistent performance throughout the engine's power range. Cold starting: choke versus primer bulb. To assist with cold starting, carburetors may use one of two enrichment methods. Choke plate closes partially to restrict airflow, thereby increasing the proportion of fuel in the mixture. This richer mixture is easier to ignite in a cold engine. Primer bulb, found on some small engines, this manually operated bulb injects fuel directly into the intake path, enriching the mixture for a faster start without using a choke. Material and durability. Carburetors are typically made from aluminum, zinc, or high-grade plastic, all chosen for their corrosion resistance and durability. These materials are important, especially with the increasing use of ethanol-blended fuels, which can attract moisture and degrade internal parts if not properly stabilized. Maintenance tips and common issues. Understanding how a carburetor works is essential for diagnosing and fixing common engine problems, such as hard starting, often caused by a clogged jet, stuck choke, or stale fuel. Rough idling or stalling may result from improper idle settings or dirty idle jets. Fuel leaks can be due to worn gaskets, damaged float needles, or a stuck float. Poor acceleration or power loss, usually tied to blockages in the main jet or improper throttle operation. Regular maintenance, such as using fuel stabilizers, cleaning jets, and ensuring the float bowl is free of debris or varnish, can significantly improve performance and extend the life of the carburetor.